Okay, let's do another example using this new method. Okay, so we're going to do 6a from our notes. Again, the first step we want to do is we want to get this side equal to 0. Okay, so we're going to have 6 over x minus 2, and we're going to have to add the 4 over. So plus 4 over 1 is greater than or equal to 0. I need a common denominator in order to put these together so that I just have one fraction. The common denominator is going to be x minus 2. Okay. Now that I have the same denominator, I can go ahead and put the numerators together. So I have 6 plus 4x minus 8 all over x minus 2 is greater than or equal to 0. Go ahead and join our like terms, and we get 4x minus 2 all over x minus 2, greater than or equal to 0. We could simplify here if you want. It is not necessary. Okay, so this was step 1. Okay, step 2 is going to set the numerator and the denominators equal to 0. So let's set this equal to 0. So I have 4x minus 2 equals 0. 4x, we're going to add the 2 over, equals 2. Divide by 4, x equals 1/2. Okay? Now we're going to set the denominator equal to 0. So x minus 2 equals 0, x equals 2. These are going to be the two numbers that we put on our number line. Okay, so let's go ahead and make our number line. 1/2 and 2. Again, we need to pick a number here. We need to pick this number, a number in the middle, this point, and a number on the right. We're going to be plugging those back into the original inequality, which was 6 all over the quantity x minus 2 is greater than or equal to -4. So I'm going to rewrite that down here by my number line. Okay, and what we're looking at is to give this a true statement. So I'm going to pick 0. That would be to the left of 1/2. So 6 over -2 has to be greater than or equal to -4. And that turns into -3 greater than or equal to -4. Is that a true statement? Yes, it is. Okay. Now we have to plug in 1/2. We need to see if this gives us a true statement so we know whether or not this is going to be a solid circle or a dotted circle. So let's plug in 1/2. Okay, so I'm just going to do 6. 1/2 minus 2 is greater than or equal to -4. So 6 all over -1.5. Is that greater than or equal to -4? Okay, so let's get out our calculators. 6 divided by -1.5 equals, that's not right, 6 divided by -1.5. Okay, so we get not a right answer. I don't know what's up with this calculator. Okay, let's try this one. Okay, so 6 divided by -1.5 equals, there we go, -4. Okay, so is -4 greater than or equal to -4? That is a true statement. So we're going to have a solid circle. Okay, now I need a number between 1/2 and 2, so I'm just going to pick 1. Okay, we're going to plug that back into the original. I have 6, 1 minus 2 gives me -1, has to be greater than or equal to -4. -6 is not greater than or equal to -4, so this is going to be false. Okay, now we got to pick 2. Well, I can look that if I plug 2 in here, that's going to make it undefined. So this is going to be an open circle. It's not going to include it. It can't include it because the denominator can never go to 0. My last thing I'm going to pick is 3. That's to the right of 2. So let's plug that in. 6 over 3 minus 2 is greater than or equal to negative 4. This becomes 1. Is 6 greater than or equal to negative 4? That is a true statement. So true. All right, so now we need to talk about our shading. So this one goes this way, and this one goes this way. This is an or because we have a gap. So let's talk about how to write this. X is going to be less than or equal to, because we have a dot, a filled in dot, so that means it's going to include it, 1/2, or X has to be greater than 2. Remember, it cannot include 2 because that would cause the denominator to go to 0. This would be our final answer.